Hello everyone. So let's start the contest problem solving, right? So we will be starting from problem C, then B, then D, all three problems, and A as well. B and A are almost similar. Just the time constraints are different. So let's start, right? So before starting, let's look at a quote that says, "Be so good that they can't ignore you," right? So in whatever field you are, right, try to be great, right? There's nothing below greatness, right? You should achieve greatness in it, right? No matter what is the condition, what are the conditions are, right? Now let's look at the problem statement. So what does the problem statement say? That you are given two integers n and m, right? And you are representing that represents a number of rows and columns of a grid respectively. You are also given a 2D integer array sources, where sources of I represents row of I, column of I, and color of I. Right. Initially with R, which are colored color of I, all other cells are initially uncolored and are represented as 0. Right. At each time, every currently colored cell spreads its color to all adjacent uncolored cells in all four directions. That is up, down, left, and right. All happens simultaneously, right? Let's say this was the color 1, right? So what will it do? All the adjacent cells, which are, let's say, up, left, right, and down, these will color them if they are uncolored, right? Color them if they are uncolored, right? So I hope till this point the English of the problem statement is clear, right? If multiple color reach the same uncolored cell at the same time, the cell takes the color with maximum value. What does this mean now? This means, let's say you are at this point. This point has a color 2 and it spreads in all the four directions, right? Now let's say here was a color, so this grid will have this cell as well. Now this cell can, let's say, have a value of 3, right? Now this cell will get influenced by this one and this one both at the same time, right? So what will happen? You will try to figure it out that if this 2 has the opportunity, this cell, let's call this cell x comma y, right? So if this cell x comma y has the opportunity to get colored by two of the cell, right? Two cells at the same time, right? At same time, then it will get colored by the one which is maximum color, which has maximum value, right? What does this mean? This cell will get colored by the 3th color, right? So it becomes 3, not 2, right? So till this point the English is clear as well. The process continues until no more colors can be colored. You need to return an integer representing the final state of the grid, where each cell contains its final color, right? Let's look at this. It says 1 and 2, the first and the last cell. uh, Let me draw it, right? uh, let's take a different color, right? We will be also changing our colors, right? Let's go. So let's say this is a 3 comma 3 cell, right? Great. The first one is colored 1 and the last one is colored 2, right? So at time equal to 1, 0, this is the condition, right? What will happen at time equal to 1? Let's mark it with red. This will influence this will influence this. There are no cell here, there are no cell here. So nothing happens. Similarly, 2 gets influence this and this. So the cell that becomes is this 1, 1, 1, 2, 2. Oh, sorry. How will this 2 get here? 2, 2, and 2, right? At t equal to 1, right? Now let's look at t equal to 2. What will happen? This 2, wait a second, yes. So this 2 will influence this will influence this will also influence this, right? And there are no more cell. This one could influence this one could influence this one as well, and no more, right? Now let's mark, wait, let me mark the ones with a color, different color, right? So let's say violet. So this one could influence this one, and this one. But you tell me, if this value has a opportunity to get colored by 1 or 2, which color will it choose? It will choose the maximum one, right? So this 1 had already been there, right? 2, 2, and 2. This was the initially state. Now this 2 will overshadow this, right? So here comes 2. This position will get overshadowed by this 2. So it will become 2. This 2 position will get overshadowed by this 2. So it gets 2. So 1 couldn't be get the place anywhere, right? So this is the final grade, which is 1 1 2 1 2 2 and 2 2 2, right? And if you look at the answer, it is 1 1 1 1 1 2 1 2 2 and 2 2 2. That is what we got, right? Now let's look at the solution, or let's first think of the solution, right? So while what are the observations that you got while you saw this test case, right? The first observation you got was the time was the most important thing, right? Time was the most important thing. What does this mean? First of all, you need to understand this is near about a graph problem, right? And we are somehow thinking of which cell will be colored at what time, right? Because see, even though like this position was colored too, but it was colored later on, not on the first instance, right? We saw all the opportunities which could be done, and after that we colored that cell, right? So time was the most important thing, right? This should be the first priority, right? Let's say, means what does this mean? Let's like think more about this line, right? Let's say I had a grid, right? So at the first instance, this cell I comma j will only influence the neighbor cells, right? And this cell, even though let's say there was a value 1 in 9, right? Even though this cell and this had only value 1, right? Let's look deep into this, right? Now what will happen is, for this time, let's say t equal to 1, this will get colored by 1. Even though there was a cell that had a value 1e9 here, it couldn't reach this cell at time equal to 1, and thereby it got colored by 1, right? So time is the most important thing. Whichever cell has the lowest time, whichever cell, what I'm writing, thinking is very important. Whichever cell has lowest time will color first, right? First, irrespective of value, right? So time is the first thing, right? But what happens if both has this have the same time, like we saw, like when the condition was something like this, right? The cell was 1 1 1, right? And there was 2 2 2. Now see, at for this cell, both comes at the same time. Then what is the second thing which your like which should be your consideration? It should be the value, right? So first, time is greater than value, right? In life as well. Anyways, so we need to create a data set or any data structure which will somehow think or make our grid look like first things that is dependent is time, then is value, right? And that's it. We are good to go, right? So what we will do is we will create a priority queue, right? Priority queue of vector, right? And we will use a comparator, right? What does this comparator do? First, it will sort based on time, right? First, we will sort based on time, and if time is same, then it will sort based on value, then sort based on value. Okay. Now let's look at the test case which we had. Right? Initially we had one. We will take it deep so that the code is easier to understand, right? So 1 0 0 0 0 0 0 0 2, right? So what happens in the first case? You had a priority queue which was empty, right? You will add in this priority queue. Let's say this is the priority queue, right? First thing you will add is the value, which are the cell which are colored, right? This cell is colored and this cell is colored. So you can add any of them at time equal to 0, right? Now if I said if the time was 0, which color will you add? The value which has the maximum. So how will the priority queue look? The priority queue top will have time equal to 0, whatever the value it had, and the cell it had, which is 2 comma 2, right? This represents time. So let me write it. First is time, then is value, then is row comma cell, right? Now the second value, which will be at time equal to 0, the value is 1 and the cell is 0 comma 0, right? Now what happens? This, we will take out this, the top of the priority queue, and mark its neighbors as the value which it is supposed to get, right? So at the time equal to 1, right, you will color these values as 2, 2, oh sorry, um, 2, this 2 gets colored and this 2, right? So this will also get added in our priority queue, right? So, and we'll pop this out, right? Now how will your priority queue look? So your priority queue will have these two values at time equal to 1, right? Okay, so let's push that, right? So even if you push that, see, time equal to 0 was the, as we were keeping our priority queue as ascending order, means the first come first serve, the time which has the lowest value will come on top. So 0 1 0 0 comes on top, and then these comes, right? So 0 is the time, let me this, yes, and what next comes, this and this, right? So at time equal to 1, the value is 2 and the cells are, this is 2 comma 1, sorry, yeah, 2 comma 1, and time at 1 value is 2 and this is 1 comma 2, right? This also gets added in priority queue. Now what happens, you pick up the next element, the top element of the priority queue, right? Yes, so what happens, you take this 0, it had a value 1, right, means this one. What will this do? Mark all its adjacent lists, right? So what, how will the list look like now? 1 1 1 2 2 2, and how will the priority queue look? It will add these two values as well. So 1, see, how will the priority queue sort? Based on time, time 1, right? One more added, which was time equal to 1 only, time equal to 1 only, right? And the values which we had were 2, so which will come on top, the two values will come on top, then 1 comes, right? And 2 comma 1, 1 comma 2, and what is this cell? This is 0 comma 1, and what is this cell? It is 1 comma 0, right? Now let's look at the next step. This priority queue gets popped out, which is the second row, first column, means this one. This will have marked attendance on these, right? So how will it go? You will mark them, right? This becomes 2, this becomes 2 2 2 2, and now we will add these two in our priority queue as well, right? So what will get added? Let's pop it. Now the priority queue looks something like 1 2 1 2, then 1 1 0 1 1 1 1 0, and now this gets added, this and this, right? That are time equal to 2, right? The value is 2 and the cell is 1 comma 1, and the time equal to 2, the value is 2 and the cell which is added is 1 2 comma 0, right? Now this will come out, right? Now what happens, this cell, if I'm not wrong, yes, this cell had, this had a value of 1 1, right? If the value is already there, then you can't change it, right? Now this value 2 comes and this will mark this, right? This one, this cell comes out and mark this 2, and you will see that at time equal to 2, the value is 2 and the cell added is 0 comma 2, right? After this you will pick out this one, but as you see in the cell, all are already colored, so means 1 comma 1 0 comma 1 cell, right? 0 comma 1 means this one, this will come out, but it's already marked, the adjacent are already marked, so you can't do anything, right? Similarly, you will carry on for all the elements which are left in your priority queue, and you will be done with nothing. So this is the final set that you will get. I hope the problem statement and the logic was clear to you, right? Let's quickly discuss the time complexity. First, let's look at the code, then we will discuss the time complexity, right? So what I have said exactly, I have written the code of that as well, right? So give me a second, right? Yes. So what I've said is we will be creating a auto comparator, right, which sorts based on the values, right? What does this mean? If two values had the same value, like means if time 1 and time 2 were same, then we will based on the value 1 comma value 2, right? If both have the same time and same value, then anyone can come at any place, that doesn't matter, right? So this is the comparator function. If I hope you know about it. If you don't know, let be a bit curious about it. How does this sort and all of that? It does nothing. It first sorts based on the time value, If two values have the same time, then it checks the value 1 and value 2 and sort based on them, right? This is the auto comparator we have created, right? Easy one. You can search it on about it and on internet. You will get many resources on it, right? So first we created an answer vector, right? All had the value 0, right? Initially all had value 0, right? We created a priority queue, right? Now what is this priority queue? It is a min priority queue, right? Min priority queue with a declare type comparator. What does this mean? This means that you will have a comparator which will see priority queue in general sorts based on the minimum value, right? It is a min heap, right? Now, if you think that, okay, if two values are same, then how will your priority queue sort? It will sort based on the second value, right? That is what we have said in this one, right? I hope this comparator and priority queue declaration is clear to you, right? All right. Now let's move to the next part, right? For we will run on the sources, right? What does this mean? We will run on all of these values. First value will be rows, second value is column, right? This is the rows, this is the column, and this is the color that is added, right? We will push the values in our priority queue. So 0, what does this 0 mean? This 0 means time, right? Then color, then rows and columns, and answer of rows comma col will be marked as colors, right? Like 0 comma 0 will was initially marked as 1 in our answer, and that's it, right? Now we have created vector of in dr and dc. You will understand what this is. Like, what does this do? Let's say you are standing at any position, let's call it I comma j, right? So every time you can go to this point, which is I comma j minus 1, right? Or I comma j, I comma j, sorry, really sorry for this. This will be, you will go to the upper value, which is I comma I minus 1 comma j, right? Pardon me for these, right? I comma I comma j, I minus 1 comma j, then this becomes I comma j minus 1, this becomes I comma j plus 1, and this becomes I plus 1 comma j, right? I hope till this point we are on the same page, right? So how does this dr change? So if you look, how is the row changing? Row is 0, minus 1, 0, and plus 1, right? You can write in any order, right? You can write it as 0, minus 1, plus 1, and 0, right? So when the DC, how will DC change? So whenever I was 0, j can be minus 1. Whenever I was 0, j can be plus 1, right? Similarly, whenever I was minus 1, it will be 0. When plus 1, it will be 0, right? So you can create this dr and dc, right? If you know a bit of graphs, I hope you know how we create dr and dc vector, right? So what we will do, we will create, while my queue is not empty, we will run through it. Auto val is q dot top, q dot pop. We are popping out the first element of the queue, right? Now time is val dot 0, whatever the first value is. Color is val of 1, row is val of 2, and call is val of 3, right? Now we will run on all of the adjacent 4 neighbors, right? New row will be row plus dr of I, new call will be call of dc of I, right? If new row is greater than equal to 0, we should be checking the conditions, right? So for this element, I hope this does not get out of my bounds. For this element, this should not go out of the bounds. Same for these, right? So you will check. Oh, really sorry, baby. Oh my god, yeah. So if new row is greater than 0 and new row is less than n, and if new column is greater than 0 and new column is less than n, and answer of new row and new column is 0. What does this mean? If whatever cell you are going on, right? You are, let's say you are standing on this, right? And you have the opportunity to go on this cell, right? If this cell is already colored as 2, you can't, even if you had a value of 100, you can't color this one, right? So that is, what does this mean? This means if answer of new row and new call is 0, then only you will proceed, right? You will mark answer of new row and new call as whatever the color which you had at the current position, right? As we saw, whatever the value time it was there and we had a color, right? So we pick this color and mark the neighbor as that color only, right? And push that value with time plus 1, right? I hope this is clear why we are pushing time plus 1, because this, then whichever cell we were currently on, let's look at it, right? Let's say we were on this cell, right? And we wanted this cell to be colored. Now this cell, let's say it got colored X, right? Now how, when will this what will be the time when this cell has the opportunity to color all its neighbor? It is at time, let's say this was at time t, then this will be at time t plus 1. I hope the logic is clear to you, right? So we will push time plus 1 colors and whatever the new row is and new column as well. And this will be marked as our answer, right? You can try to submit it, it will get accepted, right? I hope the problem statement was clear. Now let's look at the time complexity of this code. So we are traversing on all the grids and all the columns. So it will be big of n into m into we are creating a priority queue as well, right? So creating a priority queue will take big of log n comma m, right? So this is the ultimate time complexity. If you look at the constraints which were given to us, right? The constraint was n into m will be 10 to the power 5. So ultimately it boils down to 1e5 into log of 1e5, right? And this will get AC, right? So I hope the problem statement was clear to you. The logic was clear to you as well. Please do follow and subscribe if it was helpful for you. Thanks for watching, and please do comments. It gives the motivation to make more videos. And if you have any doubts, you can definitely ask on comments. Okay, thank you.